Hello class, welcome back to today's section of intensive calculus course. In today's class, we're going to talk about differentiability, what to expect, introduction, then also derivative of some elementary functions, which we're going to consider power functions and exponential functions. So, if this is your first time visiting this channel, kindly subscribe and also turn on the notification button. Don't forget to watch this video to the end so that you understand every part of the video. So, in calculus, most students, what comes in mind is differentiation and also integration. So, once you say calculus, differentiation will come in mind. We are going to talk about differentiation in this course and solve a lot of problems. So, when you say differentiation, what is differentiation? What is derivative? What does it mean at all? Now, we have some parameters which keeps on changing. It doesn't have a fixed value. So once it keeps on changing from one value to another, you have to find a stable value for it. So we want to find the gradient at each point. Assuming I'm having a sinusoidal curve like this, this is having different gradients at different points. So if I want to find a gradient of this curve at this point, then I have to differentiate this, find how this curve is changing, then I put that point in there to know the gradient of that particular point. Now, that was just by the way. Let's come to finding derivative of some elementary functions. We have ways of differentiating some elementary functions. We've talked about functions in our previous classes. If you haven't watched those videos, kindly make sure you get access to those videos so that you can get a full progress of the course. So we're going to talk about power functions, how to differentiate power functions, or some of the derivatives of power functions. In our previous video, I made mention that power functions are represented in the form x to the power 2 with a coefficient a, where a cannot be equal to 0. So if I have a function f of x is equal to a x to the power n, which is the general notation of power functions, how do I differentiate this? Okay, what you are going to do is you only multiply the power you have here n by your whole expression, then you subtract 1 from the power. So f prime of x, which is the same as the derivative of the function, is simply equal to n a x to the power n minus 1. F prime of x is equal to n a x to the power n minus 1. So this is the derivative of power functions. Whenever you are being given any power function, you multiply the whole function by its power, then you subtract 1 from that power. For example, if I give you f of x is equal to 4x to the power 5, if I tell you to find the derivative, then your solution is going to be f prime of x is equal to 5 times 4 x to the power 5 minus 1. And that is going to give me 20x to the power 4. And this is the first derivative of our function. Let's talk about exponential functions. In our previous video, as I told you, exponential functions are functions which have a constant value a to the power a function term x. So if you have this representation, that is a to the power x, a to the power y, or any number to the power a function, then we say it is an exponential function. So therefore, if I have f of x is equal to a to the power x, what will be my derivative? Am I going to multiply it by x? No. We have a way of doing this. For this class, since it is an introductory class, I'm not going to show you how we prove to get it, but I'm going to give you the general representation of the derivative of exponential functions. So whenever you are being given exponential functions, you are going to get a to the power x ln x, where this ln is called natural log. So the derivative of a to the power x is equal to a to the power x itself multiplying the expression ln of a. So what you do is, if I give you, for example, f of x is equal to 3 to the power x, then f prime of x will simply be equal to my a to the power x, which is 3 to the power x back again, multiplying the expression ln 3. So that is how we differentiate exponential function in this form. I made mention of Euler's number e, which is a constant. Whenever you have Euler's number in exponential form, e to the power x, so if I give you a function f of x is equal to e to the power x, then what will be the derivative? So f prime of x will simply be equal to e to the power x back again. When you differentiate, you still get e to the power x. Now, the question is why? I gave you that the derivative of all exponential function is equal to that exponential function multiplied by ln of the constant. Now, you know ln is natural logarithm, and natural logarithm of e is equal to 1. So I'm going to get f prime of x to be equal to e to the power x, open brackets, ln of e, which is equal to e to the power x multiplying 1, giving me e to the power x. So this gives me that the derivative of the derivative of e to the power x is the same as e to the power x. Finally, let me show you f of x being equal to ln of x. That is natural logarithm of x. These are some basic functions you'll be meeting in your calculus course. So kindly watch the video attentively so that you understand how it is being done. So f of x is equal to ln x. What would be the f prime of x, or the derivative of this function? Now, to do this, the general notation is you are going to differentiate the function I have in the argument of the ln. When I say argument, if you have a ln of something, what you have there is called the argument. So you're going to differentiate the argument, so the x, I'm going to find the x over, let me write it, x prime over the x itself. So you first differentiate what you have here, then divide it by itself. So let me take a quick example here so that I understand it. So let's say I have f of x is equal to ln 3x. My f prime of x is simply, when I differentiate 3x, as I told you, the power here will multiply the whole expression, then after I will subtract 1. So if I have 3x, I'm going to have the power here, which is 1, times 3x will be 3. Then when I subtract 1 from the 1, to be 0. So my x will turn 1. Hence I will get 3 as my derivative of 3x. All over the 3x back again. So my 3 and 3 will cancel out, and I'll get 1 over x as my final solution to the derivative. So basically, this is how power functions and exponential functions are being differentiated. I'm going to take you through how other functions are being differentiated in the next class. Kindly watch this video and also join the next class. Don't forget to like, share, and also subscribe.